We're going to keep looking at coordinate geometry here because there's another half of it. So, just as a reminder for sign diagrams, if you have any function given, so this is y equals x squared plus 5x plus 4, you firstly need to check if the graph is positive or negative. To do that, you would actually check the section up here. If that one's positive, then obviously it's a positive graph. If it's negative, then it's a negative graph. And just as a reminder, this is a quadratic, so if it's positive, which this one is, you'll have a smiley face like that. Then number 2, you need to find the x-intercepts. So let's use a box maybe. So let's find the x-intercepts first. 0 equals to x squared plus 5x plus 4. If you factorize it out, you have x plus 1 and x plus 4, giving us two values of -1 and -4. If you don't remember how to factorize, so if forgot how to factorize, you could always use a quadratic equation, which is x equals to -b plus or minus square root of b squared minus 4ac all over 2a. And that's for any equation x equals to ax squared plus bx plus c. That's if you forget. If you remember, it's okay, it should work out. And 3, you draw your sign diagram. Let's do a circle. It actually doesn't matter what shape I do, I guess. So, when you're drawing a sign diagram, you're only listing out your x-axis. As we can see, we have a quadratic, that's a smiley face, and we have our x-intercepts, so let's put our x-intercepts at -4, -1, then draw it out. Now, remember with the sign diagram, this shows that you have positive values of y, and then this shows that you have negative values. Alright, so over what domain interval is the function blah 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 decreasing? So once we have the equation, we can just draw a sign diagram to find this. Now, we need to firstly solve this so that we can find it. So first of all, we need to look at the start. That's positive, so that's good. And then once we have, what am I doing? Sorry, wrong thing. We need to find when it's decreasing, which means we need to find when the derivative is negative. That's what that translates to. So whenever you're looking at something that's decreasing or increasing, you're just finding when the derivative is negative. In other words, we're just going to use this to find a sign diagram. So let's just have a look at how this works. Let's find the derivative first. We have a third times 3 x squared plus 7 over 2 times 2 x plus 6. Simplify it down. Then once we have that, we're going to draw a sign diagram. So, as of before, that one's positive, so that's good. Then we'll solve for our x-intercepts. 0 equals x squared plus 7x plus 6. Factorizing it out, x plus 6, x plus 1, giving us x equals to -6, -1. Then we'll draw a sign diagram. We know it's positive, and goes through -6, -1. Now we want the values in which it's decreasing. So in order to find the bits where it's decreasing, I don't have another color. We want the bit that's negative there. So if you don't quite remember how to do this, just start from the lower side on the negative part, then you follow it all the way until it stops. So if you have a look there, it starts from -6, goes all the way to -1. Therefore, our solution would be x as an element going from -6 to -1. Now, you might wonder why we don't include the parts where the gradient's equal to 0. That's because the question specifically says where the interval is decreasing. It doesn't say if it's equal to as well, so we have to just leave those out. Part B. Form the equation of a tangent to the curve y equals to x squared plus ax plus 4 at the point where x is equal to -1. So this is just the same as before. We've done this before. We just need to find the gradient. So, oh sorry, not the gradient. We need to find the y value first. So y equals to -1 squared plus a times -1 plus 4. Now just a note, if you start putting this in the calculator, you should always put the -1 first in front of a, so I'm just going to fix that notation. The reason for that is if you put it into a calculator, it will actually treat it as a function if you put it the other way, so just be careful of that. So there you go, y equals to -a plus 5. So therefore our point is -1, -a plus 5, or if you like, 5 minus a. Then find the gradient. So you have 2x plus a, then sub in your x value, x equals to -1, dy dx is equal to 2 times -1 plus a, which gives us -2 plus a. Then part 3, substitute this back into the linear equation. I'm actually going to write this as 5 minus a because it's less messy. So this is just a linear equation. Y, maybe I should write that at the start, so then you know. Y minus y1 equals to m x minus x1. So here's x1, y1. Here's our m. Using different colors, as I used before, that would help. So then y minus y1 equals to m, then x minus x1. There we go. Then you just go through and solve it. Don't freak out, it's not that bad. That's a +1, so -2 plus a. Then put it all together. Alright, 2. I shouldn't use those actually, I just noticed. This is all I. So, part 2. Hence, find the values for a for which a function is increasing at x equals to -1. So we have our gradient function, which is here, and we need to show that it is increasing at x equals to -1. To do so, we need to find when the gradient is greater than 0. Because if the gradient is greater than 0, we know it's increasing. Now, because this is a linear one, we don't need a sign diagram, so we can just have a minus 2 being greater than 0. Then just simply rearrange it, a is greater than 2.